Hello students, I hope you are fine and doing well in your studies. Students, today we are going to start from where we have finished in the previous class. In this session, we will study the basic fundamental of this chapter and we will do some basic example also. So students, let's start with the chapter itself.
Hello students, now we are going to study concept of rotation in the complex number. Multiplication of a complex number z represented by point P with e to power iota theta is equal to cos theta plus iota sin theta rotates the line OP by an angle theta anticlockwise about O. Now we are going to understand it. Point P represent a complex number z. As we know, a complex number z is equal to mod z e to power iota alpha, where alpha is the argument. Now, a complex number z dash can be represented as mod z e to power iota and argument is theta plus alpha. Now it is equal to mod z e to power iota theta into e to power iota alpha, and it is equal to mod z e to power iota alpha into e to power iota theta, means this z dash is equal to mod z e to power iota alpha into e to power iota theta. As we know, z is equal to mod z e to power iota alpha. From the equation number first, we are going to substitute the value of z here. Then z dash is equal to z e to power iota theta. This is the rotation theorem, or we can say it is the basic of rotation theorem. Means any complex number z dash can be obtained by multiplying a given complex number to the rotating angle e to power iota theta. What is the meaning of this? If we are going to rotate a complex number OP by an angle theta in anti-clockwise direction, then a complex number z dash is obtained, and that complex number z dash is equal to z into e to power iota theta. This is the basic of concept of rotation in complex number. Students, let's Z1, Z2, Z3 be the affixes of the vertices of a triangle ABC. Triangle ABC is here. Describe in the counterclockwise sense. Draw OP and OQ parallel and equal to AB and AC respectively. Then the point P is Z2 minus Z1 and Q is Z3 minus Z1. And by rotation theorem, we can say Z3 minus Z1 upon Z2 minus Z1 is equal to OQ upon OP cos alpha plus iota sin alpha. And you can write this CA upon BA e to power iota alpha, and it is equal to Z3 minus Z1 upon Z2 minus Z1 mod into e to power iota alpha. Angle between two lines OQ and OP is alpha. We can write like this: AMP Z3 minus Z1 upon Z2 minus Z1 is equal to alpha. Students, one note is here. We can also write Z3 minus Z1 upon Z2 minus Z1 is equal to Z3 minus Z1 mod upon Z2 minus Z1 mod e to power minus iota 2 pi minus alpha. In this case, we are rotating OP in clockwise direction by an angle 2 pi minus alpha. Since the rotation is in clockwise direction, we are taking negative sign with the angle 2 pi minus alpha. Students, now we are going to study some basic properties of a triangle. Let A, B, C are the vertices of a triangle having affixes Z1, Z2, Z3. Then centroid of the triangle will be Z1 plus Z2 plus Z3 by 3. And if ABC is an equilateral triangle, then circumcenter Z0 satisfy the relation Z1 square plus Z2 square plus Z3 square is equal to 3 Z0 square. Coordinate of incenter of a triangle can be written as Z1 within a mod Z2 minus Z3 plus Z2 mod Z3 minus Z1 plus Z3 mod Z1 minus Z2 upon z2 minus z3 plus z3 minus z1 plus z1 minus z2, it is equal to, just like formula of incentric coordinate geometry, where z2 minus z3 is the length of sides respectively. Students, if ABC is an equilateral triangle, then we can easily prove that z1 square plus z2 square plus z3 square is equal to z1 z2 plus z2 z3 plus z3 z1 by using rotation theorem, or we can say 𝕍𝕆𝕌 method. Let it is an equilateral triangle ABC with the affixes z1, z2 and z3. Now we are going to satisfy the rotation theorem. Let this rotation is the pi by 3 angle and it is anti-clockwise direction, and this rotation is again pi by 3 with anti-clockwise direction. We can write for this rotation BA can be obtained by rotating BC into e to power iota pi by 3. This is the vector BA and vector BC. And for this rotation we can say CB vector can be obtained by rotating CA vector into e to power iota pi by 3. Now we are going to simplify it. What is the BA vector? Position vector of A minus position vector of B. And mod of BA and BC is equal, so we cancel out the mod. Then it is equal to BC. What is the BC? Position vector of C minus position vector of B into e to power iota pi by 3. This is the equation number 1. And BC, it is Z2 minus Z3 is equal to CA Z1 minus Z3 e to power iota pi by 3. Now we are going to simplify it, or we can say equation first and second solve simultaneously. We are going to substitute the value of e to power iota pi by 3 from one equation to another equation. Then we can say that it is equal to Z1 minus Z2 is equal to Z3 minus Z2 into, it is Z2 minus Z3 whole upon Z1 minus Z3. Now we are going to cross multiply it. It is Z1 minus Z2 into Z1 minus Z3 is equal to Z3 minus Z2 into Z2 minus Z3. Now we are going to multiply it. It is Z1 Z3 minus Z2 Z3 minus Z2 Z1. It is Z1 Z3 Z2 Z3, and here is the Z1 square also. Z1 square means it is Z1 square Z1 Z3 minus Z2 Z1 and plus Z2 Z3 is here is equal to Z2 Z3 minus Z3 square minus Z2 square plus Z2 Z3. Z2 Z3 is cancelled out. Now we are going to simplify it. It is Z1 square plus Z2 square plus Z3 square is equal to Z1 Z2 plus Z2 Z3 plus Z3 Z1. First equation is proved here. Now we are going to prove the second equation also. As we know, triangle ABC is an equilateral triangle. So we can say that length AB is equal to length BC is equal to length CA. What is the length AB? Length AB can be written as mod Z1 minus Z2 and BC Z2 minus Z3 and CA is equal to mod Z1 minus Z3. Now we are going to prove this second formation. We are going to find 1 upon Z1 minus Z2. It is equal to Z1 bar minus Z2 bar whole upon Z1 minus Z2 into Z1 bar minus Z2 bar. Now we are going to apply the formula of Z1 minus Z2 into Z1 minus Z2 bar. Then we can find it. It is equal to Z1 bar minus Z2 bar whole upon mod Z1 minus Z2 whole square, and let it is the K. That's why we can write it is Z1 bar minus Z2 bar upon k square. This is equation number first. Similarly, we can find 1 upon z2 minus z3 is equal to z2 bar minus z3 bar whole upon k square. This is equation number 2. And 1 upon z3 minus z1 is equal to z3 bar minus z1 bar whole upon k square, equation number 3rd. Now we are going to add these three equations, then we can easily find that sum of all these three equations is equal to 0. Students, point number 5 is here. If ABC is an isosceles right angle triangle and right angle at C, then we have to prove this. Let it is a isosceles right angle triangle ABC with the affixes Z1, Z2 and Z3 respectively. Student, this is the 90-degree angle. By using the rotation method, we can say that CB vector can be obtained by rotating CA vector into e to power iota pi by 2. What is the CB vector? Position vector of B minus position vector of C is equal to CA vector position vector of A minus position vector of C into e to power iota pi by 2. It is iota. Now we are going to square on both sides. It is equal to z2 minus z3 whole square is equal to minus z1 square plus z3 square minus 2z1 z3. Now we are going to simplify it. It is the minus z1 square minus z3 square plus 2z1 z3. And now again we are going to simplify it. It is z1 square plus z2 square is equal to, here it is the twice of z2 z3 plus twice of z1 z3, and here is the minus 2z3 square. Now we are going to subtract twice of z1 z2 on both sides, here and here. Left hand side is equal to z1 minus z2 whole square, and it is equal to twice of z1 minus z3 into z3 minus z2, and this is the right hand side of our question. Students, here is the equation of perpendicular bisector. What is the meaning of equation of perpendicular bisector? We are going to form a relation in the z, and z is a variable such that distance from the point A and B is always remains same from the point Z. That's why point Z lies on the perpendicular bisector of line joining A and B. That's why the equation of line which is perpendicular bisector of the line segment AB is the combination which contains Z. That's why you can write mod of Z minus Z1 is equal to mod of Z minus Z2, because distance AC is equal to BC, and this is the equation of a perpendicular bisector line. Now we are going to simplify it. Then we can find that Z1 bar minus Z2 bar plus Z bar Z1 minus Z2 is equal to Z1 square minus Z2 square. Students, now we are going to study one of the most important topic of the complex number. This is the equation of circle. What is the circle? Circle with center represented by the complex number z0 and radius r has the equation z minus z0 mod is equal to r. What is the meaning of this? As we know, the definition of circle is that circle is the locus of a point which moves in a plane such that point always remains at a fixed distance from a given fixed point. That fixed point is called the center and that distance is called the radius. So if P is this point and the coordinate of P is Z, then we can say distance PC is equal to R, and by the definition of complex number we can write that Z minus Z0 is equal to distance PC is equal to R. This is the equation of circle where Z0 is the center and radius is R. Now we are going to simplify it. Squaring on both sides, it is Z minus Z0 whole square is equal to R square. What is the meaning of mod z whole square? It is equal to z minus z naught into z minus z naught whole bar is equal to r square. Again simplify it. It is z minus z naught z bar minus z naught bar is equal to r square. Now simplify. It is z bar minus z naught bar z minus z naught z bar plus z naught bar is equal to r square. Z bar is mod z square minus z naught bar z minus z naught z bar plus it is mod z naught square is equal to r square. Let z naught is equal to minus a, then we can write mod z square, and this is the minus a, that's why we can say it is a z bar plus a bar z plus b is equal to 0. What is the value of b? The value of b is mod of z naught square minus r square. That's why r square is equal to mod of z naught square minus b. We are going to write a radius is equal to within a square root mod of a square minus b. So we can write the equation of a circle like this: mod z square plus a z bar plus a bar z plus b is equal to 0, where center is minus a and radius is within a square root mod a square minus b. This equation is written here, and this is called general equation of a circle: z bar plus a z bar plus a bar z plus b is equal to 0, where b is a real number and the center of this circle is minus a and its radius is within a square root mod of a square minus b. Students, point number C is here. The equation of a circle described on the line segment joining Z1 and Z2 as a diameter is z minus z1 into z bar minus z2 bar plus z minus z2 into z bar minus z1 bar is equal to 0. Now this angle is 90 degree. We can write angle between line PA and PB is the 90 degree. Now we are going to write this system like argument of z minus z1 upon z minus z2 is equal to 90, or you can say plus minus 90. If argument is 90, then this complex number is purely imaginary complex number. That's why we can write z minus z1 upon z minus z2 is a purely imaginary complex number. For a purely imaginary complex number, we can say a complex number and summation of their conjugate is equal to 0. So we are going to write here plus z minus z1 upon z minus z2 whole conjugate is equal to 0. Now we are going to simplify it. It is z minus z1 whole upon z minus z2 plus it is z bar minus z1 bar whole upon z bar minus z2 bar is equal to 0. Now cross multiply it. It is z minus z1 into z bar minus z2 bar plus z minus z2 into z bar minus z1 bar is equal to 0, and this is the equation in Z, and it is called equation of circle in diametric form. Students, point number D is here. The point with the affix Z1 lies inside and outside to the circle z bar a z bar plus a bar z plus b is equal to 0 if for the inside category we put z1 in the place of z, then this expression should be less than 0. If this expression is greater than 0, then we can say point z1 lies outside the circle. Students, one important point is here. If z is a variable point such that argument of z minus z1 upon z minus z2 is equal to alpha, it is the angle between the line P and PB, where alpha is not equal to n pi and alpha is a constant angle, then the locus of z is an arc of a circle. Means z lies on this arc if angle is alpha is here. Means if in any question this statement is lies, then you can find that the locus of z is the arc of a circle. Student, point number 1 is here. If mod of z minus z1 upon z minus z2 is equal to k, and if k is not equal to 1, then it is a circle. And if k is equal to 1, then point z lie on the straight line. Point number 2 is here. The equation z minus z1 square plus z minus z2 square is equal to k represent a circle if k is greater than or equal to half of z1 minus z2 whole square. Students, let's ABCD be a cyclic quadrilateral such that ABCD lies on a circle having the affixes z1, z2, z3 and z4 respectively. It is clear that angle A plus C is equal to pi. What is the angle A? Angle A is this, means angle between the line AB and AD, and this is the form by which we can write the angle between A and B. In this chapter, angle between the line AB and AD can be written in this formation, and this is the angle A, and angle between the line CD and CB is written like this formation, and as we know, the sum of both the angle is pi, and if sum of angle is pi, then we can say the product of these angle is pi, because argument of m plus argument of n is equal to argument of m into argument of n. If this angle is pi, then this complex number is purely real complex number. That's why you can say that z4 minus z1 upon z2 minus z1 into z2 minus z3 upon z4 minus z3 is a purely real complex number. Thus the points A, B, C, D taken in order would be concyclic if this product is purely real. This is the one of the most important concept for the concyclic points. Students, regarding the circle, here is one of the most important fact. What is this? If a point z lies outside the circle z minus z0 is equal to r, then z minus z0 mod should be less than r. And if point z lies exterior region to the circle, then z minus z0 mod should be greater than r. Students, now we are going to study de Moivre's theorem. If n is an integer, then cos theta plus iota sin theta whole power n is equal to cos n theta plus iota sin n theta. We can easily prove this setup. Let first complex number is cos theta 1 plus iota sin theta 1, and second complex number is cos theta 2 plus iota sin theta 2. This is the polar form. If we are going to write this polar form into exponential form, then we can write it is e to power iota theta 1 into e to power iota theta 2. Then after simplification, this complex number is equal to e to power iota theta 1 plus theta 2. Now we can write it like this. It is cos theta 1 plus theta 2 plus iota times sin theta 1 plus theta 2. There are only two complex number in the multiplication form. Then we can obtain that their argument is the summation of individual arguments. Means we can say that if there are n complex number, then their argument will be add up, and all complex number having the same argument, that is theta, then after multiplication up to n times we can find a complex number that is equal to cos n theta plus iota sin n theta. This is the basic statement of de Moivre theorem. Students, if n is equal to p upon q, where p and q are integers and p and q have no common factor, then cos theta plus iota sin theta whole power n has q distinct values, and one of the values is equal to cos n theta plus iota sin n theta. Students, we have to remember one thing, that If we are going to write the binomial expansion of cos theta plus iota sin theta whole power n and equating the real and the imaginary parts, we can get that cos n theta is equal to cos n theta minus nc2 cos n minus 2 theta into sin square theta and so on, and sin n theta is equal to this, and after obtain sin theta and cos, we can find tan n theta also, and the combination of tan n theta is written here. Students, now we are going to study roots of a complex number. What is the meaning of roots? Let a complex number is z and we are going to find nth root, that is equal to z to power 1 upon n. If z is equal to r cos theta plus iota sin theta and we are going to find z to power 1 upon n where n is the natural number, then first of all we have to write the complex number into polar form and then raise the power 1 by n. It is the r to power 1 by n, and this is the generalized form of the argument. It is cos 2k pi plus theta upon n plus iota sin 2k pi plus theta upon n. Here it can be noted that any n consecutive values of k will save the purpose. What is the meaning of this? We can find the n roots of this complex number by substituting k is equal to 0, 1, 2 up to n minus 1, and these consecutive values of n gives the nth roots of this complex number. If we will substitute the value n, then we can get the similar result which can be obtained by these values. So there is only n consecutive values of k will save the purpose. Students, now we are going to study application of 𝕆𝕋𝔼𝕆 theorem. This is a fundamental theorem and has various applications. Here we will discuss few of these which are important from the examination point of view. First is the nth roots of unity. Let x be an nth roots of unity. Then x to power n is equal to 1, and 1 can be written as cos 0 plus iota sin 0, and generalize it, it will equal to cos 2k pi plus iota sin 2k pi where k is an integer. Now if x is an nth roots of unity, means we are going to find z to power 1 upon n, that is equal to cos 2k pi upon n plus iota sin 2k pi upon n by using 𝕆𝕋𝔼𝕆 theorem. After substituting the value of k is equal to 0, 1, 2, n minus 1, we can find all nth roots of unity. Consider alpha is equal to cos 2 pi upon n plus iota sin 2 pi upon n and write it like this: e to power iota 2 pi upon n. Then n nth roots of unity are alpha to power t. What is the meaning of this? If we are going to substitute the value of k, different values of k, means k is equal to 0. If k is equal to 0, then root will be cos 0 plus iota sin 0. Yes or no? What is the value of cos 0? Cos 0 is 1 and 1 root is 1. It is okay. Now second root. For the second root, we are going to substitute the value of k is equal to 1. Then what will happen? It is cos 2 pi upon n plus iota sin 2 pi upon n, that is alpha. Got it? If k is equal to 2, then what will happen? It is cos 4 pi upon n plus iota sin 4 pi upon n, and we can write it like this: e to power iota 2 pi upon n whole square. And as we know, this is the alpha, means you can write it is alpha square, and further alpha cube, alpha to power 4, and so on. That's why nth roots of unity are alpha to power t, where t belongs from 0 to n minus 1. Nth roots of unity are given by 1, alpha, alpha square up to alpha to power n minus 1.